And here we are with our next lesson. In our Systems of Linear Equations unit, we're looking at 7.4. We're going to solve a system of linear equations by substitution. So we already know there are three ways to solve these linear systems. We've already looked at the graphing method. Now we're going to step away from graphing and look at how we do this by substitution. We can use algebra to solve a system of linear equations. So you think of algebra, you think of letters, variables, you think of manipulating them, switching them from left side, right side. All those skills that you've learned are going to come together here. The method we're going to use here is called solving by substitution. When using substitution, we transform the system of equations into a single variable. So we know that most of our systems have two variables, usually they're x and the y. Essentially what we're going to do is we're going to eliminate one of those variables, and then when we only have a single variable left, we can then solve what that variable stands for. So let's look at how we do this. Example number 1. Solve the following system of linear equations. So we've got 2x plus y equals 0, and then 6x plus y equals negative 10. So the first thing what you want to do is you want to choose one of your equations and one of your variables to isolate. So I'm going to say that we're going to isolate the x. And we're going to choose either equation. I like the first one. So I'm going to choose 2x plus 2y equals 0. And I'm going to isolate the x, which means get the x all by itself on either side of the equal sign. So the first thing I do is I pull this 2y over to the other side. Leaves me with 2x equals, when this switches sides, it turns negative 2y. Now I still don't have x by itself, I've got 2x. So it's multiplication, I'm going to divide. Divide by 2. So these will cancel out. I've isolated my x equals negative y. So step 1 is to choose one equation and isolate one variable. Next thing I do is I substitute into the other equation. So my other equation was 6x plus y equals negative 10. So what I do now is I know that my x is equal to negative y. So I'm going to change all my x's in this equation to negative y's. So this becomes 6, and this is multiplication, so it's 6 times negative y plus y equals negative 10. So essentially what I'm doing here is now I'm going to find out what the actual y variable is. This didn't give me the actual x number because it turned out to be an equation, negative y. When I solve for the y in this form, I'm going to get an actual number. It's going to be part of my solution to my answer. So 6 times negative y, that's negative 6 y plus y equals negative 10. I'm going to combine my y's. Negative 6 plus 1 is negative 5y equals negative 10. And I'm going to isolate my y, so I'm going to divide it by negative 5. My y equals positive 2. So if you think my actual answer is the single point, the xy coordinates that are going to satisfy both equations, I now know that that y coordinate is 2. So that's a pretty big number I need. So how do I get my y? Well, I need to substitute my y of 2 into either of the equations. So now I sub the y value into either equation. I can choose. So I like the first one, so I got 2x plus 2y equals 0. So I'm going to take my y of 2 and change all my y's into 2. This gives me the 2x plus 2 times 2 equals 0. Well, I know that 2 times 2 is 4, so I'm going to get 2x plus 4 equals 0. I'm going to bring my 4 to the other side, so flip the sign. 2x equals negative 4. Divide by 2, divide by 2, and my x value is going to be negative 4 divided by 2 is negative 2. So I've just solved my system. I know that my x is going to be negative 2, and my y is going to be positive 2. So I go back up to my solution here, and the solution is negative 2 for the x, positive 2 for the y. That was a bad color there, so I'll just undo that. But our answer here that we know is going to satisfy both equations is right there, negative 2, 2. Now, of course, it's nice to be 100% certain in math. So can we do anything to make sure those are the answers? Well, we can do a little check. So I'm going to go into the green color here. And I'm going to take both equations and make sure that negative 2 and 2 are the ones that work. So the first equation was 2x plus 2y equals 0. Change my x's to negative 2. 2 times negative 2. Plus my y's go to positive 2. 2 times positive 2 equals 0. This is negative 4 plus 4. And negative 4 plus 4 is 0. And yes, that comes down. So we have a good check for the first equation. But of course, we talked about this already. We need to do both equations to make sure it works perfectly. So the second equation is 6x plus y equals negative 10. 6 times negative 2 plus 2 equals negative 10. Negative 12 plus 2. Negative 12 plus 2 is negative 10. And yes, negative 10 equals negative 10. So I've got a good check right there. So I've done the work. I've checked it. I know that answer is 100% accurate. So again, just to review the steps. First step is to isolate one of your variables. Substitute into the other formula to get either your x or your y answer. Take that, put it into one of the equations to get your second variable. So now let's try another example. This one's a little more complicated. In this case, we've got fractional coefficients. So you can see here that the numbers in front of my x and my y's are going to be fractions, not whole numbers. If you're under this situation, what you're going to do is find the LCM, the lowest common multiple, for all denominators. When you find the LCM for all denominators, you're essentially going to remove them. So let's see how this works. So before I even start trying to isolate, I'm going to change my equations. So find the LCM of this first equation, 2 and 3. So the LCM of the denominator, well, what's the LCM of 2 and 3? Well, the answer is 6. So what I do now is I take each part of my equation and times it by 6. So I'm going to get 6 times 1/2 x minus 6 times 1/3 y equals 6 times 4. So watch what happens here now. If I have 6 times 1/2, well, that's 6 divided by 2, which is 3x. If I have negative 6 times 1/3, that's negative 6 divided by 3, which is negative 2y, equals 6 times 4 is 24. So by multiplying every term by the LCM of the denominators eliminates all my fractions and changes all my coefficients to full numbers. Let's do the same thing with my second equation. LCM of 8, 6, and 2. In this case I've got 3. So the LCM of the denominators is 24. Now remember, you can go 8, 6, and 2. Start figuring out which is the lowest common multiple. I could get 8, 16, 24, 32. I get 6, 12, 18, 24, 30. I can get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and there I see it, 24. Now this was all from chapter number 3. If you need a review on LCM, go to chapter 3, please. So I'm going to take each term and multiply it by 24. So I'm going to get 24 times 1/8 x minus 24 times 1/6 y equals 24 times 3/2. Now you'll notice I put the brackets around the variables this time. It doesn't matter. Around what you're multiplying or by the variables, it does the same thing. So this is 24 times 1 divided by 8. Well, that gives me 3x. Minus 24 times 1 divided by 6. That'll give me minus 4y. And we want to watch this a little bit. 24 times 3, that's positive 72. 72 divided by 2 is 36. Now remember, when you are doing numbers times fractions, it's the number times the numerator, and then divide by the denominator. 24 times 3 divided by 2. So here we have our two equations which we are now going to work with. Once we have them, I'm going to choose one equation and solve for one of the variables. Now it doesn't matter which one I choose at all. So I'm going to choose my first one here, and I'm going to solve for the x. Or isolate the x. I like that term better, so I'll just put isolate the x. So I've got 3x minus 2y equals 24. I'm going to bring the 2y to the other side. It's going to flip its sign. So 3x equals 2y plus 24. And usually I like my variables before my constants. I'm going to divide everything by 3. So my x is now going to be 2/3 y plus 8. So I've now isolated the x. I now choose my second equation, and I'm going to sub in for x. So whenever I see an x, I'm going to have to write this entire equation, 2/3 y plus 8. So I've got 3 times my x, and now I write down 2/3 y plus 8 minus 4y equals 36. I'm going to take my 3 and distribute between both of my variables inside my brackets. So now remember, that's 3 times 2, which is 6, divided by 3, which is 2y. 3 times 8 is positive 24. And then I've got my minus 4y equals 36. So the first thing I'm going to do here is bring this 24 to the opposite side, so it's going to flip its sign. So I've got 2y minus 4y equals 36 minus 24. Combine both my y's and my numbers. 2y minus 4y is minus 2y equals 36 minus 24 is 12. I'm going to divide by negative 2. Divide by negative 2. And my y will equal negative 6. So right there is my y portion of my answer. I know the y is going to be negative 6. Now I got to solve for the x. So again, I can choose which one I want to go into. And I just like using the first one all the time, so I'm going to go a little line here. I'm going to go, the original is 1/2 x minus 1/3 y equals 4. So now I'm going to change all of my y's to negative 6. 1/2 x minus 1/3 times negative 6 equals 4. So I'm going to multiply this through, so I get 1/2 x. Remember, this is negative 1 times negative 6, which gives you positive 6. Divide by 3, which gives you 2. So 1/2 x plus 2 equals 4. Bring the 2 to the other side. It'll flip its sign, so that'll be 1/2 x equals 4 minus 2 will give me positive 2. And now how do I get rid of a half? I times everything by 2. That'll cancel, leave me with x. Times this by 2, 4. So my answer now for the x is 4. So my coordinate points that satisfy both equations are an x of 4, y of negative 6. Let's do a quick check to make sure that I've got my answers. My first equation is 1/2 x minus 1/3 y equals 4. Change my x's to 4's, my y's to negative 6. 1/2 times 4 minus 1/3 times negative 6 better equal 4. So half of 4 is 2. And again, watch what we're doing here. Negative 1 times negative 6 is positive 6. Divided by 3 is positive 2. 2 plus 2 is 4. And yes, 4 does equal 4, so that does work. And we'll choose our second equation here. 1/8 x minus 1/6 y equals 3/2. X's go to 4, y's go to negative 6. 1/8 times 4 minus 1/6 times negative 6. and this should equal 3 over 2. So 1 times 4 is 4. 4 over 8 reduces to 1/2. Keep it as a fraction. Negative 1 times negative 6 is positive 6. Positive 6 divided by 6 is positive 1. Positive 1, another way we can write that is 2 over 2. And then we add my fractions. Common denominators, I have those. 1 plus 2 is 3 over 2. 3 over 2 does equal 3 over 2. So I've got a good check. So you can tell that there's an extra step when we have fractional denominators, but it's no problem. Once you've got rid of the denominators, you solve for or isolate one variable, plug into the other one, solve for the first variable, plug into the other equation, solve for number 2. Let's flip the page. And now let's kind of tie everything in again. We've got some words where we're going to have to make our equations and then isolate them using substitution. So an investor buys a total of 360 shares from 2 stocks. So that's an important number. The price of one stock is $35 per share. The price of the other stock is $45 per share. And when you're done buying these shares, you've spent a total of $1,500. So we're going to have to set up 2 equations from this information. So first thing you got to do is identify your variables. Now hopefully we realize that the variables are going to be stock number 1 and then the other stock, stock number 2. So I'm going to let y equal stock 1, and I'm going to let x equal stock 2. So what do we know about this? Well, we know that when we're buying the stocks, we're buying 360 shares. So however many of stock 1 plus however many of stock 2 is going to be 360. So there's my first equation. Stock 1 plus stock 2 is going to be 360. Now you'll notice I told y was stock 1 and x is stock 2. I could have easily switched those around. The order is a little bit of what we're not used to. We're used to having our x's first and then our y's, but it really doesn't matter. Now what else do we know about these? Well, we know the prices. So however many of stock 1 I buy is going to be $35. However many of stock 2 I buy is going to be $45. And when you add these together, I spend a total of $15,000. So this is 35 times the number of stock 1 plus 45 times the number of stock 2, and this should equal $15,000. Again, if you look at it, the first sentence kind of gives us our first equation. The second and third sentence gives us our second equation. So we've got our equations. They're not fractional coefficients, so I can go right to it. I'm going to use one of the equations to isolate one of the variables. I think it's pretty easy to see this will be a much easier equation to work with. So I've got y plus x equals 360. Now which one do we want to solve for? Let's solve for x. So I'm going to bring the y to the other side. It's going to flip its sign. X equals negative y plus 360. So I know what my x is worth. Now let's plug it into the other equation. So it's sitting right here. And I'm going to change all my x's to negative y plus 360. 35y plus 45 times negative y plus 360 equals 15,000. So I'm going to simply take the 45 and times it by everything in the brackets. 35y. Now watch your signs here. You got positive 45 times negative y is negative 45y. And of course 45 times 360, we can pull out a calculator, but we're going to get positive 16,200 equals 15 grand. Okay, now we're going to bring this 16,200 over to the other side. It's going to be subtracted. So I get 35y minus 45y equals 15,000 subtract 16,200 is negative 1,200. I'm going to combine my y's. 35 minus 45 is negative 10y equals negative 1,200. We're going to divide this by negative 10 and negative 10. Y equals 120. Positives, because we have a negative divided by a negative, and a positive 120. So there is the y value that is going to satisfy my equation. Let's now go to the other equation because it's a simpler one. We've got y plus x is 360, and we're going to change the y to 120. So 120 plus x equals 360. I'm going to solve for the x, which means I bring the y to the other side. It is positive, so I'm going to subtract it. X equals 360 minus 120 is 240. And there I've solved for my x equation. So I'm going to have 120 of stock 1. I'm going to have 240 of stock 2. Let's do a quick check on this to make sure that I am 100% right. So I'll go into green, do my check. So the first one was y plus x is 360. My y was 120. My x was 240. 120 plus 240, 360. So yep, that's a check. Now my other equation, that was 35y plus 45x equals 15,000. 35 times 120 plus 45 times 240 equals 15,000. 35 times 120 is 4,200. 45 times 240 is 10,800. These two added together is 15 grand, which is exactly what I was hoping for. I've got a check, so I've got a good solution here. So when you're using substitution, there's a few steps you got to do. You've got to isolate one of the variables in an equation, flip to your opposite equation and solve for the first variable. Take your answer, plug it in to one of the equations, solve for your second variable. Both of these give me my answer. I've got to check to make sure I've got 100% accuracy, so I know I'm doing things perfectly. A lot to take in today, but let's go to page 425. 1 from the A's, 6 from the B's, and 1 from the C's.